In this video, we will learn about the strategy design pattern and how to implement it using C++ code. Strategy is a behavioral design pattern that allows us to define different algorithms as classes and be able to interchange their objects. For example, if you need to get to a destination, you could walk, take the train, ride a bike, or drive your car. Each of these is a transportation strategy. Let's learn how to implement the strategy design pattern using C++ code. At the top of the program, we will include the memory and algorithm header files. Next, we will create a class named strategy. Inside of here, we will use the public access modifier and have a virtual destructor for our class that we set equal to the default keyword, and a virtual function that returns a string named doAlgorithm that takes in one parameter, a string named data. Next, we will create a class named context. Inside of here, we will have a pointer to a strategy named myStrategy. Then we will use the public access modifier. Let's add a constructor for our class. After that, we will create a function with a void return type named setStrategy that takes in one parameter, a pointer to a strategy named strategy. Inside of this function, we will set myStrategy equal to a call to move with strategy passed in. Then we will create a function with a void return type named doSomeBusinessLogic, inside of which we will check if myStrategy is not null. If so, we will create a string variable named result that we set equal to a call to myStrategy's doAlgorithm function with the string 5012943 passed in. Then we will output result and then a new line to the console. Else we will output the string strategy isn't set and then a new line to the console. Then we will create a class named concreteStrategy1, which extends the strategy class with a public accessibility. Inside of this class, we will use the public access modifier and override the base class's doAlgorithm function. Inside of here, we will create a string named result and pass in data to its constructor. Then we will make a call to the sort function and pass in begin with result passed in as the first argument, and end with result passed in as the second argument. At the bottom of the function, we will return result. After that, we will create a class named concreteStrategy2 that extends the strategy class with a public accessibility. Inside of here, we will override the doAlgorithm function. Inside of this function, we will create a string named result that we pass data into the constructor of. Then we will call the sort function and pass in begin with result passed in as the first argument, end with result passed in as the second argument, and greater with a type of int as the third argument. At the bottom of the doAlgorithm function, we will return result. Time to test our code. Let's go inside of C++'s main function. Inside of here, we will create a pointer to a concreteStrategy1 named concreteStrategy1, which we will set equal to a new concreteStrategy1 object. Then we will create a pointer to a concreteStrategy2 named concreteStrategy2 that we set to a new concreteStrategy2 object. Next, we will create a variable of type context named context with concreteStrategy1 passed into the constructor. After that, we will output the string sort regular and then a new line to the console. Then we will call context.doSomeBusinessLogic. Next, we will output a new line to the console, and then print out sort reverse, and then a new line to the console. After that, we will call the context's setStrategy function and pass in concreteStrategy2. Finally, we will call context.doSomeBusinessLogic. When we run the code, notice that the first strategy sorted the numbers in ascending order, and the second strategy sorted the numbers in descending order. We successfully implemented the strategy design pattern using C++ code. Great work! We use the strategy design pattern when we want to use different variations of an algorithm, and be able to switch from one algorithm to another at runtime, when we have a lot of similar classes that only differ in the way they perform some behavior, like sorting numbers in ascending versus descending order, when we want to isolate the business logic from the implementation details in our code, and when we have a large conditional statement that switches between different variations of the same algorithm. Advantages of the strategy design pattern are that we can swap the algorithms used at runtime, We can isolate the implementation details of an algorithm from the code that uses it, and we can introduce new strategies into the program without having to change the context. Disadvantages of this pattern are that it can overcomplicate the code if we only have a few algorithms that rarely change, and the code must be aware of the differences between strategies to select the appropriate one.